All right, so let's just dive in. Who is SmartBear? SmartBear was founded in 2009. I'm talking to you from our headquarters here just north of Boston, Massachusetts in Somerville, but we have over 11 offices around the world, and we cater to over 6.5 million users, and this is with our 22,000 customers. We have 5 free tools right now. Some of our most popular ones are Soap UI and Swagger Hub. And I work, I'm one of the lucky 525. I think this needs to be updated. But we're growing on a day-by-day basis, and I'm just one of the lucky 525 employees that we have here. All right, so I know we're going to be talking about Load Ninja today, but if you're not familiar with any of our other tools, we have a tool for every step of the way in the software development lifecycle. So it's, if you're working on the development side, if you're working from the testing side, even to the ops side, doesn't matter if it's on the UI layer or the API layer, we work pretty diligently here to cater to every step in the process and to make sure that, all of our tools work in a fairly seamless manner. So, in the upper right-hand corner here, you can see Load Ninja, which we'll be talking about today about load testing from the UI side, but really want to make sure that everybody's aware of some of the other SmartBear products out there, as well as some of the native integrations that we offer within each of these tools. So, today we'll just be talking about Load Ninja, and also from a CI/CD integration aspect, we understand that sometimes it might be prudent to schedule performance test runs. So we'll also be talking about Load Ninja's integration with your Jenkins platform. All right, so quick brag side. I'm not sure if it's bragging if we've actually been recognized, but really want to, shine some light on some recent recognition that SmartBear gained. So Gartner is a research and marketing firm, and every year they do a Magic Quadrant study. And let me see if I can zoom in on this here. Excellent. So, with this study, they grade test automation companies on 2 main criterion. The first being that of the ability to execute, and the second being the completeness of vision. And so you can see that we are now in the leaders quadrant, something that we're very proud of, because we now jumped 11 spots to now be in this quadrant. Just want to make sure everybody's aware, because we understand that when you're looking at different tools, there's always 2 sides to an evaluation. One being, okay, what can the tool actually do for me? But also you want to know who you're going to be investing in from a company standpoint. Just wanted to make a brief introduction here with this study. All right, so that's really SmartBear as a whole. Let's really dive into what we're here to talk about today, and that is performance testing. Now, performance testing itself, the term, it's really on an umbrella term, because it's such a broad word that can be used to cover many different aspects of load test or performance testing. So, the definition that I like, it's a type of software testing that intends to determine how a system performs in terms of responsiveness and stability under load. So this is important because we could have the best web application. For our demo today, we're going to look at it in terms of a pet store e-commerce application where we can shop and look at different pets that are being sold online. So this may be the coolest application with the best UI, but at the end of the day, how can we measure the efficacy of this web application if it has all these cool features when only one user is accessing it? But when multiple concurrent users are accessing it at the same time from around the world, it really doesn't matter how cool that UI is if it takes 3 seconds to load a page, 5 seconds to load a page, because ultimately users will abandon it before they can actually experience that cool UI layer. So performance testing helps understand how applications behavior under an expected user load, whether that's first testing that small scale layer, 10 to 15, just to make sure it works at a smaller scale, and then scaling up to make sure that it tests or that it performs under the full duration of load that we will anticipate. It also allows us to isolate and fix issues that arise under the user load and determine peak system capacities. This is especially useful. Let's again take it from our e-commerce demo perspective. We understand that every Thanksgiving there's Black Friday. Then with e-commerce now there's that Cyber Monday. We need to determine how our application is going to perform when all these users are signing on that Monday morning. This is why performance testing has become such an important part of the software development process. So as I mentioned before, performance testing itself is a very it's a huge umbrella term that can cover many different types of performance testing. First, there's load testing. So if we want to determine how the application just behaves with a large number of users, capacity testing actually determines the max threshold of users that can support. So we can determine, after how many users, if we add that marginal concurrent virtual user, does it violate our SLAs or those service level agreements that we have to adhere to? Stress testing allows us to determine how applications behave under extreme number of users. Testers purposely tried to determine the breaking conditions here. This is the sort of testing that is especially useful for that Cyber Monday scenario previously described. Soak testing determines how an application behaves under extended periods of load, also called endurance testing. And then spike testing determines how applications behave under spikes of load, or varying parameters from one end of load to another in short bursts of time. So why do we performance test in the first place? And the answer lies in the fact that there's an established 2-second barrier. And so what is, studies have been conducted, and 2 seconds is the maximum amount of time that a user will tolerate for a particular web page to load. 53% of users will abandon a site if the load time is greater than 3 seconds. And we have learned that a 1 second marginal addition of load lag time can cost $1.6 billion. And we can see that users are becoming increasingly impatient. As technology increases, as we are, as web applications are becoming more and more advanced, people expect things on a much shorter time period now. So there's an important trend that we can recognize from these features here. And it's the fact that end users at the end of the day drive development and testing. And companies that learn this are able to develop and ship functional qualities on a faster timeline, and they're able to implement a sort of shift left mentality where you're able to do small functional tests in the same software development lifecycle that load testing is done, and in this manner really cut down on testing time and ship the best version of the best version and the best quality of software out to the public on the shortest possible timeline. So within any load testing tool, it's going to come down, there's always going to be 3 basic components. And these 3 basic components kind of take us through the story of performance testing, of how we go about creating tests and analyzing the results. So the first step is always going to be the test creation. You can code this, you can record the actions, but at the end of the day, test creation really just refers to what transactions do I want to incorporate in my model for how end users are behaving with my web application. So for an e-commerce application, for our pet store application, we might want to include a login and a logout process. We might want to include searching for different pets, adding them to our cart, going through a checkout process. All of these different use cases would be separate recordings, and we can use these recordings to create new tests. So once we have all of these tests created, we can then go into the configuration file, and this is where we will designate, how many total virtual users we want to run in a load test. We'll designate, the ramp up time. Do we want all the users signing on to our e-commerce application at the exact same time, at time 0? Or do we kind of want to simulate a more realistic scenario where users are slowly ramping up one right after another until they reach the full peak capacity that we designated for the maximum number of virtual users in our load test? We'll also talk about duration-based tests versus iteration-based tests, 2 of the most popular configurations that are available in load testing. And we'll talk about that a little bit more in depth later on in the demo. And then once we have the files, or like that web test creation, once we have the configuration file that incorporates all of the web tests and the amount of time and the number of users that we want to run, once we run this load test, then we will get the metrics, then we'll get the reports that are indicative of how users are interacting with our web application. And at the end of the day, if we integrate with a CI/CD tool, or if we just manually execute these tests, once a new version of our UI is deployed, ultimately we want to run a comparison report just to ensure that the latest version of our application corresponds with one that has an improved performance factor. So there are some current roadblocks in the current performance testing process, and right now, with the way organizations think they spend their time, they spend a lot of their time in the test creation process, then spend a moderate amount of time in the test maintaining process. Maintenance really refers to, if your UI changes, do I have to re-record a script? If just an element changes, do I have to modify the think times? Do I have to modify the script before playback, before verification of a test can be validated? And then the test execution process is probably the third the time that people think they spend the most in after those 2. The fact is that, like many other processes, what people are actually doing doesn't necessarily line up with what they think they're doing. And at the end of the day, with the way load testing is currently done, we are spending a lot of time maintaining our test cases. And at the end of the day, we are spending the most time in the validation portion of each test case. So in order for we create a test whether we code it, whether we record our actions and then allow a computer to interpret that and generate a script for us. In order to verify that this script can then be used in a load test, we kind of have to use the mathematical process of induction, or kind of the domino theory. In order to ensure that this script can be used multiple concurrent times down the line, we have to make sure that it plays back successfully one additional time. Once we know that it works for the base case, and then it will work for the next following case, then kind of like dominoes, we can ensure that it will work all the way down the line, as one will impact the other. So ideally, we'd like to place a focus on the test planning stage. By doing this, we cut down on all other stages because we're allowing testers to shift their focus from how web tests or user transactions are created, how the web application is created, what variables need to be processed, where we can actually abstract all of that out of the equation, and then really shift the focus to how users are interacting with an application and using that information to expedite the test creation process. So just to summarize, currently there are some current load testing challenges. For one, it can sometimes be very inefficient to create those user transactions. This is mainly due to the fact that we're using protocol-based recorders. So what's a protocol-based recorder? It's one that captures, the HTTPS layer traffic. It's one that, gets the get and post responses of the traffic, and that's going to be your protocol-based recorder. At the end of the day, your testers would normally have to go through this protocol-based recording, not only correlate each get and post response to different pages that we navigated to, but we also have to make sure that certain variables are accounted for. So down the line, when we show our pet store application and we're going through a sign in, sign out process, in many applications, not just e-commerce, banking, every time we sign in, there's going to be some sort of session ID that's captured. When we're creating these tests, that session ID then has to be parameterized as a dynamic variable and then subsequently propagated through all the rest of the requests. So it takes a lot of time for testers to go through and comb through the layers of code, make these dynamic variables that are created at runtime, and then make sure that they're accounted for all subsequent transactions. So we either have to be very well versed in performance testing tools to know how to do this right off the bat, or we have to take a lot of time out of developers' day to understand, okay, where are these session IDs stored? How do I go about replicating, client-side JavaScript that needs to be replicated ahead of time? So we can see that, these are two, this is a huge bottleneck right now in the current way that performance testing is done. So secondly, at the end of the, homegrown load generators produce inaccurate load. In other words, at the end of the day, the entire goal of performance testing is to model end user behavior as closely as possible. So we have to come up with realistic scenarios or realistic web tests that are going to record those user transactions. We don't want to just search for, if we're signing in with one username, we don't want to just keep that signing in with that same username and password every single time, because we want to account for all possible use cases and really generate the most accurate load. And at the end of the day, users are signing in or going through our web applications on real browsers. It seems pretty axiomatic, but some tools right now are using WebSockets to interpret the get and post response from our protocol-based recording. And it's based on that proprietary coded WebSocket to interpret those post and get responses that then render a emulation of a browser. So we really want to find a way that can take that emulation of a browser out of the equation and kind of really return metrics that are more aligned with the end user behavior. And that kind of leads us to our third challenge that is currently being presented. Results that aren't standardized and aren't actionable because they're not being run on real web browsers. How can we go to our developers now with these metrics? And at the end of the day, we might run it on one load testing tool that uses WebSockets. And if we run it on another load testing tool that also has WebSockets, because the way the WebSocket is coded is proprietary, if the code differs in any manner, our response times will also differ based on that WebSocket's ability to interpret those get and post responses. So this is where we really wanted to highlight Load Ninja before getting into the demo. We're going to show how we can record these user transactions on a real web browser and how we can configure and scale these real web browsers to run an accurate load test. And then we'll see and diagnose any errors that are occurring in real time and really have a seamless handoff process from our testing team to our development team so that everybody can really work together on one cohesive SaaS-based platform to run tests and analyze results, ultimately leading us to get the best version of our platform out on the shortest possible timeline. All right, so we are going to take a look at Load Ninja now. And Load Ninja is our SaaS-based load testing tool here at SmartBear. It will load test the UI layer. And just to make sure that everybody can see what I'm saying, can you see the three tables on the screen? And if you could just let us know through the chat box or raise your hand that you can see the Load Ninja platform with the logo in the upper left-hand corner. Excellent, thank you guys so much. Okay, so this is Load Ninja. What all we need to do to get started, and one of the things I want to highlight is because this is a SaaS-based tool, we can bring on as many testers and as many developers onto this single license platform as possible. So all we need to do is navigate to our user settings. If as my boss here, as important as he is, he's listed 3 times, but if we wanted to add all of our testing team, all of our development team, we would add that here. Now, a common practice in performance testing, and in most testing for that matter, is to test on some sort of QA environment or some sort of internal facing application. So I'm just going to, launch a poll just to get an understanding of where you're launching these performance tests right now. If you're launching in a pre-production environment, just so we know what to show here in Load Ninja. Okay, so results are coming in it's a pretty resounding yes. So just so you can understand, okay, my application is an internal facing application. How can a SaaS-based tool help me load test? So the only download that's required is the endpoint. So based on our system architecture, based on our operating system, we would download the corresponding endpoint. And just by signing into the endpoint using the exact same username and password credentials that we use to sign into Load Ninja, that's how we can log in, and now we can generate traffic and record and play back against our local application. So the way Load Ninja is set up, it's, everything is sorted based on projects. And so if I navigate to our project that we started for today's webinar, we can see just as there, the three basic components of all of load testing, we sort those components within separate tabs here. So our user transactions, the ones that we need to record, are going to be stored under the web test tab. Our configuration files, the ones that will denote how many virtual users, how long we want to run the load test for, that's going to be stored within the load test scenario tab. And then the results will be displayed here in the test runs tab. All right, so let's go ahead to get started. I'm just going to navigate within a new tab here. And within a separate browser here, I'm going to type in our sample pet store e-commerce application. Okay, it may not have had all the fancy UI features that we talked about beforehand, but for our demo application, it'll do just fine. So here's our e-commerce application. We're going to create a script where we can log in, log out, and simulate that. We also want to search for different products as well. We'll be able to emulate that as well. So just as I opened a new tab here in my real browser and entered in the URL, that's really how we're able to shift the focus of knowing how the web application is created, where all the objects, or how all the objects are created, where the session IDs are, and really just allow our testers to focus on the fact of how end users are interacting with our application. And we can do this by utilizing a real web browser. This is an external application. All I need to do is supply the URL. Since different elements of the UI respond at different rates, depending on the underlying resolution, we can choose various resolutions here on Load Ninja. Again, because we want to emulate real user behavior as closely as possible. But for today's demonstration, I'm just going to use the 1920 by 1080 resolution. All right, so now we're seeing kind of that embedded browser here. At the end of the day, it is a real browser. So now just to create tests, we can interact with our application as an end user would. So we can take anybody off the streets here in Boston, and as long as they know their username, as long as they know their password, then theoretically they can be the ones that are creating this test here in Load Ninja. We can see that there is no protocol-based recording. There's no underlying HTTP, HTTPS traffic. All of it gets translated off on the side here to the different pages that our user navigates to, and the corresponding actions that take place on each page are logged under each step on the side. All right, so if you recall earlier, I said that a major time sink in conventional load testing is done at this point, and it's to accommodate those dynamic nuances that are normally present. Those ones that we normally have to have a firm understanding of how the application is created, or go back and forth from the testing team to the development team to know where the session ID is stored in that sign-in process, how to make it a dynamic variable that can then be replicated across or propagated through multiple calls after this initial sign-in process. A lot of these dynamic variables take a lot of time to account for, and this has to be done before playback, before the verification process. In Load Ninja, we're able to abstract all of these dynamic nuances for you. So we can play back and validate that this web test can be used in a load test scenario immediately after the recording is finished. So you'll see Load Ninja on the left-hand side iterate through each action that was previously recorded. Each think time or each time between each event was captured and is now being played back. And we're it's keying in the exact same username and password that we previously recorded. And we can easily validate that this test can be used in a load test scenario. And all of this is done now by shifting our focus to have a better understanding of how users are interacting with our web application. So one question that came up was a well-defined test case should always end with a final state of n+1. Why? So I used on the principle of induction to refer to the validation process and why we should play back, because ultimately we're taking a recording or the base case and we want to make sure that it will play back at one additional time. So it's really just the automation process itself in order to ensure that it will work at the masses it will work for 10 virtual users, for 100 virtual users. We first want to make sure that it works one additional time after we recorded it. Once we record it successfully, this is our base case. Once we prove it works one additional time, this tells us that we can now use it in our load test scenario. Let's see. So one question that came up is peak performance determined as the optimal number of users that can be loaded without response and performance being affected. What test contributes to this capacity or spike? This would be, if you recall from the beginning, this would be our capacity testing. What number of virtual users can be added, and then at what limit, or what is our virtual user limit that we can add? That when we add that marginal one virtual user, that our SLAs or our response times are invalidated. That would be handled under the capacity testing. One question that came up, can we use Load Ninja scripts locally for organization audit purposes, or maybe use source control tool like Bitbucket? Not right now. This is all cloud-based, and we try to allow team collaboration through the user management section. But again, something that we can definitely bring in to the attention of our product team. Can we export internal IDs, for example, session IDs, which are correlated automatically using Load Ninja, but not visible on the UI? So we would need, because this is being correlated automatically by Load Ninja, there's really no need for it, but it's also difficult. This would be a difficult process to incorporate because they're not visible on the UI layer. If they're maybe perhaps at the, on the underlying document the document object model layer, perhaps, but right now this is something that we cannot do. All right, so I'm going to save this script and we'll call it our login logout process. One additional script that I want to go over is our how we can employ data-driven testing. So that process of using one test case over and over again to drive more realistic scenarios. And we can again do this through accessing our pet store application. I'll illustrate this by searching for one particular product one time, namely a golden retriever. We're seeing the results and then navigating back to the home page here. Now, Load Ninja is able to abstract not only the user input, but the resulting page that shows as a result of the differing inputs every single time. So now I can add a data bank in the format of a CSV or TXT file. And Load Ninja allows me to map that data bank to the originally recorded user input. So we can see that this would be very useful if we're doing a, many different usernames, many different passwords. We can easily record one use case and make sure that all of them are addressed so we can simulate that end user behavior, based on how users are actually interacting with the web application. All right, so we can also change, just because let's say the search button changes or this search text box changes and we want more users, our UI team does some research, they want more users to search so we can get more hits and more products being sold. So they're going to move the search bar to the middle of the screen. So instead of having to re-record the entire application, we can either, we're still going to click on the input box. So we can either record a new action and insert it while deleting this old one, or we can just upload the new optimized XPath, the new CSS selector, the new XPath that corresponds with the updated location of the search bar. And in this way, we don't have to mandate that testers spend a lot of time and effort reinventing the wheel, so to say, and re-recording from scratch. All right, so now what I'll add is a validation. This is, again, implementing that shift left mentality to add small functional tests at the same time that that load testing is being done. Here, I'm going to add this validation to this text validation, and we can add these text validations because we can see elements at the underlying document object model layer. And so I'm going to call this a golden retriever check. And because we're data driving this, anytime that we're searching for anything other than a golden retriever, it will log it as an error. So you may be asking yourself, why, when I run a load test eventually after I configure this, will I want an error to purposely show? And this is because we want to show what sort of results, what sort of metrics, what sort of tools and resources are available to our development team at the same time that our testing team is analyzing the results. All right, so now I'm going to save. We'll call this save and validate. Now that I have all of my recorded user transactions, I'll click save and create load test scenario or that configuration file. So this is where I'm able to easily scale. If we designate 10 concurrent virtual users, we will spin up 10 real browsers for you every single time with clear cache, clear cookies, so you don't have to account for these things that would implicitly bias the response times. Here, you are getting the most accurate form of load because at the end of the day, your real users are interacting with a real web browser as well. So I'm going to not only include my search and validate, I'm going to include my login, logout. Something that we recently added is the ability to specify various geographic regions and distribute the load among those regions. So if we not only want to verify, how are users within the United States, namely the eastern part of the United States, interacting with my web application, we want to see a breakdown of, maybe people in London, maybe people in Frankfurt are experiencing it differently. Again, this all comes back to modeling my end user behavior as closely as possible. So we allow for this to be accounted for here in Load Ninja. We can do duration-based testing. We can do iteration-based testing. The main difference here is, do you want to run for a specified time, or do you want to run for a specific count of transactions? So, as the name implies, duration-based testing, it will run for a given amount of time, whereas iteration-based testing, if if I specify 10 if I specify 10 iterations, then for each virtual user, it will run through its corresponding web test 10 times based on the distribution of the web tests. All right, so I'm going to run a quick 5-minute duration-based test. Ramp up time, this refers to how users are ramping, as the name implies, ramping up to that full 10 virtual users. Is it a very gradual process? Is it all at once over 1 minute? Here we can designate, that interval or the number of steps. So if we want all users coming in and, logging into our application at time 0, we'll add 1 stamp. Alternatively, if we add 5 steps here, then every 12 seconds until we reach 10 users, 2 additional virtual users will be added every 12 seconds. We can modify the playback time. And additionally, if an error occurs, we can allow our developers to debug that error in real time and hold on to that error-prone virtual user. So one question that was asked: how will the load testing be done if we only recorded 1 case? We had to record 1 case first just to make sure we have the user transaction. Now that we verified that it played back for 1 time, now that we know that the recording will work under the stress of 1 virtual user, we can now scale it up and configure it in this load test. And now we will see the results of how it can perform under the stress of multiple virtual users. One question that came in is, when a page is being tested and both success and failure are on the same page, how will Load Ninja know success is different from the failure? So we'll be able to log the resulting response. Is this is everything okay? Then we'll log the 200 response, or 202 response. Is there a broken link? We will respond with the 404 response. We will log the corresponding response code, and we'll be able to see and pause that error-prone virtual user to see, is there 1 element on the page that's not being loaded, and really identify what's the real cause or the underlying root issue leading to the failure. So one thing while this is running, I do want to point out that, if we run a test, whether it's through our CI/CD tool, if we run with a CI/CD tool, or if we run with, just manually execute tests, as soon as we have multiple load test results, we have the ability to add comparison reports to ensure that the latest version of our application corresponds with one that has the improved performance layer as well. So we'll get into the step metrics and the errors on the individual test level, but I really wanted to point out how we can look at the comparison between 2 up to 4 past test runs, and even look on and add customized charts or dashboards. And based on specific metrics that we're concerned with, we can look at these results here. All right. So let's go back to our projects. And we'll see the results coming in on that a live 5-second resolution. One thing that I want to point out is the virtual user inspector. Now, imagine a marketing studio, and okay, we're testing in a pre-production environment or a internally facing application. Now, if we have a physical product that we're making, we're going to go to a marketing studio, and before we release it to the public, we're going to sample a test group, and we're going to look through that two-way glass and see how is this test group interacting with our product. What changes do we have to make? Let's get a better understanding of how potential real customers are interacting with our product. Take the same concept and now apply it to load testing. The virtual user inspector here allows us to sample different virtual users that we've configured in our load test. And now we're able to see, based on which virtual users are being sampled with various scripts or various web tests that we've included in this load test, we're able to see, in a live format here, are there any time degradations, like before even diving into the charts or the statistics, that we can experience for ourselves through that two-way glass? So if there's a 5-second time degradation experienced, let's say on the login, logout process, we would be able to see that from an overhead perspective before even diving into the charts and the statistics. So in the virtual user debugger, this is where we will log those errors. We'll be able to reply with a corresponding response code. The reason we're seeing a 200 response code here is that we added a validation that will purposely fail, even though everything on the page loaded successfully. So normally in load testing, there is a translation process that occurs. Our developers are used to working in that HTTP archive report format, and this is only accessible to them after the testers has finished running through their test data, after they're able to convert the data into the format that is usable and actionable for our developers. Now we can take that entire translation process out of the picture, pause each error as it's running during the load test, and now we can quickly identify while the load test is still running and take quicker action to see what can we change on our end to make sure that we can better the platform before it's released to production. So again, interacting through a JavaScript terminal, very similar to a console browser that our developers would normally use, and interacting with elements through that document object model level. We hold that error-prone virtual user in place. You can see that we're here on the home page. And we even provide a network waterfall tracing how each element on this page was able to load. We can look at the individual requests, the response, a breakdown of the timings, and at the end of the day, provide the format that our developers need to understand what's the underlying issue with this particular error. And we are doing this without a translation process. And because there's no translation process, there's no element of human error. All right, so what we're looking at now are the script and step durations. This graph tells us how our users interacting with a particular process. We can specify which page or which process within a page we want to see. So if we want to see how long the home page took, how long users are spending on the sign-in page, we'd be able to filter that out and display it in real time here. Now we understand that understanding user behavior and reporting metrics based on this is only part of the equation. We still want to understand what can we do on our end. What are the response times? How is our application responding? So we provide the navigation timings out of the box at the exact same time. So looking at the response times, but also understanding how the network is able to handle our application, because at the end of the day, maybe the time degradation that we're experiencing, this sudden spike isn't truly, on us or our internal team's fault. But with Load Ninja, we can now, let's say there's a very high DNS time that, happens to correspond with, a spike in the duration time. Now, although, correlation isn't necessarily indicative of causation, we can take a closer look at this and even look at the statistics. And now in this tabular format, we may be able to go forth and look into this in a little bit more detail. So go to our DNS servers with this empirical data and say, we believe this might be the underlying reason. We might have written everything on our end of our web application flawlessly or to the best of our ability, but our users are seeing a 3-second time degradation, and we have reason to believe that it's on your end. So this really encapsulates how Load Ninja is not only able to provide metrics that is useful to our internal team and doing everything we can to get the best version of our application out to the public, but also providing the metrics necessary to address any external variables that may be contributing to performance issues. So this is Load Ninja. This has been taking the stress out of stress testing. We hope you have a better understanding of, what performance testing is, some of the basics around it, how, some of the current challenges that we're facing in the industry, and how we can best, beat these challenges and take a unique approach to model our end user behavior as closely as possible while returning, meaningful metrics to our team. Again, we very much appreciate the time that you took today, and we look forward to hearing from you soon and look forward to presenting another webinar in the future. Thank you.